So for the second lesson of Chapter 3, we are really kind of picking up where we left off in Section 1, and we're taking all that vocab that we learned in Section 1, and we're now throwing it into what if these two lines are now parallel. In Section 1, it was all about the vocab. These lines were not yet parallel, but what we're going to see in this one is if they are parallel, then it creates some really important relationships between these angles. And one way that you'll note that lines are parallel is when they put these little triangles on them. That's the notation to tell you that lines are parallel. When I draw them, or if I'm marking a diagram, I just do this to show that lines are parallel, right? So kind of that same triangle look, but this is kind of a common notation that we use to show that lines are parallel. But anyway, here's what we got. When these two lines are parallel, then corresponding angles, alternate interior and alternate exterior angles are all now congruent. So if you look at these guys, corresponding angles such as 1 and 5, such as 4 and 8, 3 and 7, or 2 and 6, those are all now congruent relationships. So 1 is congruent to 5, 4 is congruent to 8, so on and so on. Right? So alternate exterior angles and interior, same thing, are also congruent. So 4 and 6 are alternate interior angles. They're congruent if the lines are parallel. 3 and 5 are congruent if the lines are parallel. So alternate interior angles. That bell is following me. All right. 1 and 7 are alternate exterior angles. They are now congruent to each other if these lines are parallel. And 2 and 8 are congruent to each other if these lines are parallel. So you get all these congruent relationships. Here's the one that's different. Consecutive, or remember that means same side. So same side interior angles are supplementary. They add to 180. Right? So same side interior angles add to 180. So if I look at ones like 4 and 8, so 4 and 8 would have to add to 180. Sorry, 4 and 5. 4 and 5. So 4 and 5 are consecutive interior. They add to 180. 3 and 6 are consecutive interior. They add to 180. Right? If you took a more extreme drawing, like I'm going to go real extreme here and do something like that. So if you look at consecutive interior angles like this one and this one, those are obviously not congruent, right? No way. He's acute. He is way less than 90 degrees, and this guy is obtuse. He's way more than 90 degrees. So in an extreme drawing, it becomes really apparent that there's no way these are congruent angles, and so that's when we're going to see these as supplementary angles. They add to 180. It's the only ones, though, that you got to remember add to 180. All the others are congruent. They do remind you of some other relationships that we've learned before. They're all named over here, so this is kind of a great one to look at. Great example, because it throws in a lot of the old vocab as a reminder. So don't forget about linear pairs, right? Two angles that form a line, like 1 and 2, like 3 and 4, 5 and 6, 7 and 8, right? Those are linear pairs, and we know that they are supplementary, right? That's an old one. Vertical angles, such as 2 and 4, right? Vertical angles are congruent. We learned that in chapters 1 and 2. The vertical angles are congruent. So 2 and 4, 1 and 3, you could say 5 and 7. So I just want to make sure we don't forget about those. Those are still in play here as we're looking at these groups. And I think we named all the special ones here. So let's try a few for practice here. So if angle 3 is 102, so we're going to call this guy 102. What else do we know, right? So they do want us to name the postulate or the theorem that we're using. If you go back up to this one, let me just show you something really quick. Starting on page 180, you'll start seeing the official names for all of these. So we have the corresponding angles postulate, So we can abbreviate that, maybe CAP, corresponding angles postulate, when we go to write it, because otherwise it gets to be a whole lot of writing as we're writing all this all the time. So that's one of them. And again, it just says that if these two lines are parallel, right, then corresponding angles are congruent. So that's the idea we've already talked about, but you need to know the name. So it's called the corresponding angles postulate. As you continue on, you'll see that's the only one that's the postulate, by the way. The other three are theorems. So, and remember, theorems are ones that actually come with a formal proof. You can prove these are true. The postulates are more of like a generally accepted concept. So we have the alternate interior angles theorem, we have the consecutive interior angles theorem, and we have the alternate exterior angles theorem. So those are just the official names. And again, they're all based on the idea of if the lines are parallel, then they go on to say that what's true about them, right? So if the lines are parallel. And then there's one more I want to show you before we finish off with the remaining examples, just while I have the book open. Sorry, it's just moving a little slow. As I'm recording and clicking through other websites like this, sometimes it moves a little slow. At the bottom of page 182, we're also shown the perpendicular transversal theorem. So on this one, you can see that not only are these lines parallel, but I'm also seeing that line T, the transversal, is perpendicular to the two parallel lines. So here's what this one says. It says if line A is parallel to line B, as we can see those, and line A is perpendicular to line T, then here's what we would be allowed to say. Well, then B must also be perpendicular to line T. So here's what they're giving you. They're saying, okay, we're going to tell you that these two lines are parallel, and we're going to tell you that line A is perpendicular to the transversal. So then you can conclude, well, then line B must also be perpendicular to the transversal, because these are parallel, right? So that's the other one I wanted to make sure that you saw out of this. So let me take you back to the notes page so we can finish these off. If I can get this thing to open for me. Give it a sec. So for the last ones, again, we're looking at all these relationships. We got parallel lines. So again, you can see that P and Q are parallel because of those triangles. And you can see that M and N are parallel because they got the common triangles as well. You will notice that because they use single triangles for P and Q, they had to use double triangles for M and N because they want you to recognize that these are separate from those, right? So these are obviously not parallel to those lines, so they always want to use different notation for that. So angle 5, how could we figure out angle 5? So right here, they told us that angle 3 was 102. Angle 5 is an alternate interior angle to angle 3. And because these lines are parallel, right, remember you can always kind of cover up the line that we're not using here. So he doesn't exist right now. In fact, I'll even do this. So you're M and you're N. Let's cover up the one we're not using. Make this more clear. So 3 and 5 are alternate interior, and we just saw that the alternate interior angles theorem says that they are congruent, since these lines are parallel. So 3 and 5 would have to be the same, so angle 5 is 102, and they want you to name the postulate or theorem that we use to get it, right? And so we use the alternate interior angles theorem. So we can abbreviate, but you got to get it all in there. Let's jump over here to angle 6. So how can we figure out angle 6? Well, we just figured out this was 102. So now you actually have two different ways you could come up with angle 6. The new one is to recognize that 3 and 6 are consecutive interior. And as we already learned, that consecutive interior angles are supplementary. So if he is 102, he would have to be 78. And if you took that route, then we would say we use the consecutive interior angles theorem. So consecutive interior angles theorem. Well, what else could we have done? Well, look at these guys. We got a linear pair, right? So I could have also used the linear pair postulate to say that these two angles are supplementary, and I still would have got 78, but you could have gone a different route. Look at angle 11. So let's cover up what we don't need at this point. So if I'm looking at this information, so now M is the transversal. So angle 11 is corresponding to angle 3, right? And the corresponding angles postulate, remember that's the only one of the new group that's a postulate. The corresponding angles postulate says that angles 3 and 11 are congruent. So 11 would also have to be 102. And that is our corresponding angles postulate. Angle 7. Let's go back to these guys. So angle 7, couple ways you could get angle 7. The new one would be to say corresponding angles, right? So if that's 102, then a corresponding angle would also be 102. And if you took that route, we would call that angles postulate. But you might also have recognized vertical angles, right? So if 5 is 102, I could have said, well, then 7 is 102. And if I took that route, I would say it's the vertical angles theorem from our last chapter. Two more. Angle 15. Let's go to, and a couple different ways you could do this. As you start filling in more, you get more and more options on how you want to do this. Let's just pick one way. So if I look at this information, angle 15 is corresponding to angle 7. Therefore, he is also 102. And if I took that route, that's my corresponding angles postulate. You could have used corresponding angles right there as well. 11 and 15 would also do the same. And then the last one, angle 14. Let's see. Angle 14, again, several ways you do this now. Let's just do this. Angle 14, I can either use consecutive interior angles and say that they are supplementary, and that would give me a 78 for him. And that would have been consecutive interior angles theorem. You could have also just used a linear pair postulate. Linear pair postulate says that these guys are supplementary. The other one that we did learn in Chapter 2, when we see a linear pair, we can also call that the supplement theorem. The supplement theorem, which came up at the very end of Chapter 2, said that if you have a linear pair, that they are supplementary. And so you can also use that. That would also... So let's take a look at some of these guys for how we can put them to use. So on this one, getting into a little more with the algebra and putting the algebra to use with these topics. So they're giving us some information up here about angles 1, 2, and 3. And we have to use that information to figure out what x equals and what y equals. So here's where that knowledge from the previous page of your notes, page 11, is going to come into play. So first of all, you got parallel lines, which is super important because, as we just learned in the first half of this lesson, those parallel lines make a whole lot of special relationships out of these angles, right? So as we start looking at these, as I look at angles 1 and 2, which are named right here, I now know that angles 1 and 2 are congruent by the corresponding angles postulate, which means 3x plus 15 must equal 4x minus 5. Right, and so that's how they set that up and went on to solve for x. As far as the y value, so this was angle 1 with an x in it. This was angle 2 with an x in it. Angle 3 is right here. Right, so what do we notice about the relationship between 2 and 3? Right, well, as I look at 2 and 3, I can see that angle 2 and angle 3 are congruent to each other because they are corresponding angles. Because they're both connected to line Q, that's the transversal, and these two lines are parallel for those guys. So 2 and 3 are corresponding angles, and so I can set them equal to each other and solve from there. So do notice on this one that before they set this one up, they first solved for x and plugged it back in. So when you see up here for angle 2, they said, well, if x is 20, then 4 times 20 minus 5 makes angle 2 75 degrees. So they took those steps first before setting up this information here, right? So they first had to figure out that angle 2 is now 75 degrees. Now they can say, well, then 75 must equal 5y, right? Because that's what was given to us right here. Okay, so there's kind of some in-between work there that you're not seeing, but we know it's getting applied in order to set this one up. So let's try a few of these on our own. We're going to give you some different looks here, but the super, super important thing to recognize are the parallel lines. So as I look at these, I got parallel lines, I got a transversal right here, and one thing that will help you is if you can ignore, somehow get rid of the information that you don't need to help make these things look a little more familiar to you. So for example, what if we did this? So if I were to cover up that line right there, now it looks a little more like what we're used to seeing, right? I have parallel lines going this way. I have my transversal going this way. And in fact, you know what would make this even more obvious? So watch when we do this. So not only am I going to cover up this line for a minute, what if I extended these parallel lines? So do you see, if we do this, how we're now really clearly seeing the relationship that we've learned this chapter, right? I got the two parallel lines. I got my transversal right here, right? So this is what we need to see, is that relationship. They're going to give you different looks. It could look like a parallelogram like this one does. It could look like a triangle like this one did originally before I changed it. So they're going to give you those different looks. Come back to this idea, right? That I got two parallel lines cut by a transversal. So let's look for some of those relationships that we know are true. You'll notice in a case like this, I'm solving for x and y. Well, I don't want to pair up x and y at the same time. I want to look for relationships that involve one letter. So if I look at this angle and this angle, right, those are ones that both involve x. So let's pair those up. So if I pair those up, I can see those as corresponding angles. So that's my reasoning. When they say explain your reasoning, it's corresponding angles, is what allows me to say that 5x minus 5 is congruent or equal to 4x plus 10. So for explain your reasoning, we could say it's the corresponding angles postulate. And then I could go on to solve for x. So I'll just do that real quick. Subtract the 4x over, add the 5 over, and we get x is 15. Now I can use that to solve for y. And there's two different ways you could do this. So it's like pick your favorite method at this point. I could go with a linear pair, which says this plus this, add to 180. Or I could use my consecutive interior angles theorem to say that this one and this one add to 180. So either way, we could set this up to solve for y. I'm just going to use the new one because that's what they're trying to get you used to in this chapter. So first things first though, before I pair these up, well, let's just do it now. I know that 6y minus 4 plus 4x plus 10 adds to 180. That is the consecutive interior angles theorem. But we now know that x is 15. So I can now replace or substitute 15 in for x. So that I only have one letter in this equation, and that's super important. Now you could go on and finish solving, so you can do the algebra. And just to keep the video a little shorter, I'll let you do that part on your own. You can solve for y, and that would be the end of it. So let's jump over to these guys. So as I look at this, again, I got to recognize these types of relationships. No matter what kind of a drawing they throw at me, I'm looking at parallel lines. right? And one thing that might help you in some cases, I don't have to erase lines, but if I just extend some of these lines, that might give you a clearer picture as to where your relationships are. So sometimes just doing this can help you. So just by extending those lines, might look a little more familiar to you as to what we've already done, right? Because now it looks like ones like that we've already seen. And so maybe that would help you as well. As I solve for x and y, again, I want to pair up ones that go together. So I don't want to match up these two guys right off the bat, because then I'd have an equation with two different letters in it. Let's pair up those, right? They both have an x, so let's use that information. When I come to this side, I'll pair up those guys together. From here, I know that these are consecutive interior angles, right? Here's all I'm looking at, is that right there, right? And so that makes these consecutive interior angles, which we now know are supplementary. So I know that 5x plus 11x plus 4 adds to 180. And my reason that I would put with that is the same thing I put right here, consecutive interior angles theorem, right? And then you could just simply use some algebra to go on to solve for x. If you did that, 16x plus 4 equals 180. Subtract that 4, and we get this. And then just divide both sides by 16, and I get that x is 11. So once you know that, you now have two options on how you want to solve for y. I could just pair these up and do the same thing. I could say that this plus this equals 180, and I could solve for y. And totally okay if you do that, but what else could you do? If I know x is 11, well, if I plug that in right here, I now know that this angle is 5 times 11, or 55 degrees. So if I wanted to, I could now say that 55 plus this equals 180, and that would be okay. So there's several different ways you could go from here. Let me just use this information. So I can now say that 55 plus 13y minus 5 equals 180. And again, those are consecutive interior angles theorem. And then you could go on to solve for y. Right? So several different ways you could approach it at that point. Here's the last two we'll go through. Again, when they say explain your reasoning, make sure you throw in the postulate or theorem. Just a good way for you to get to know what those are and how to write them and what they're called and all that good stuff. So feel free to pause and work ahead of me on this. See how you're doing. This is a very familiar figure. We're going to see a lot of this, these four lines, as we've already seen. One relationship we can get right off the bat is here. Right? This is a linear pair. And so we could just simply say that 2y plus 106 adds to 180. And that would just be, you could either say linear pair postulate, you could say supplement theorem. That's what we learned at the end of chapter 2. That works. So there's actually a couple different reasons we can use at this point. So if we go on to solve for y, subtract your 106, and I get 74. Divide, and we get y is 37. So we now know that angle y is 37, or sorry, the value of y is 37. Let's go on to solve for x. A couple things you could do at this point. I'm just going to take the easy route and say I have consecutive interior angles right here. So x plus 106 must equal 180, and again I would explain my reasoning by stating consecutive interior angles theorem. And if I go on to solve, I figure out that x is 74. And then from here, you'd have to actually do a couple things from here. But this is a great example. So if you look at this, if I don't see a direct relationship, because there isn't one for what I have so far, what I can do is get there by filling in other things that I know. So for example, I could recognize vertical angles. and say, well, if that's 74, then that's 74, right? And that's just one possible route that you could take. But now I can say, well, looking at these, I know that this plus this equals 180 because these are now consecutive interior angles. And so now I could say that 4z plus 74 adds to 180 because of consecutive interior angles theorem. So you might, on occasion, have to fill in other information to get what you need. And then you could finish solving that one on your own with some algebra. Let me move on to the last example. So for this one, again, try to identify the relationships that we are familiar with. So for example, I got a linear pair. So that's one thing I could say. As I look at the bottom of this, I know that because this is a line, that this plus this plus this must add to 180, right? And so one thing we could do on this is say that 2x plus 90 plus x adds to 180, right? Because all lines form 180 degrees, right? So you could, if we needed to explain my reasoning on that, if we needed to really name something specific, we could have said probably like definition of a line or something like that. No real angle, no real theorem or postulate fits this one, but we could still explain it by saying that all lines are 180. So if we went on to solve for x, let's do that real quick. So 3x equals 90, so x is 30. So now that we know that x is 30, what else can we figure out? Well, if we look right here, I have alternate interior angles. So I know that 2y is equal to 30 by the alternate interior angles theorem. And that tells me my value for y. And now you could either use a linear pair or you could use consecutive interior angles to say that 30 plus z equals 180. And so that would finish it off and get you your final variable. So that'll do it for section 2. It'll be acceptable to say that this is 78. So, but a lot of relationships, a lot of vocab that we got to be familiar with at this point. But that is the end for section 2.